Good morning, children. We proceed on to exercise 8.2, problems based on conditional probability. Question number 13. There are 1,000 students in a school, out of which 450 are girls. There are 1,000 tells me n of s is 1,000. In that 450 are girls. If I take A to be the event of selecting girl, P of A would be 450 by 1,000. Out of the 450, 20% of the girls studying in class 11. So we have the next event as class 11. Take B as students in class 11. What is the question? What is the probability that the selected student is from class 11 given that the selected student is a girl? From standard 11 given that she is a girl. Standard 11 we have taken in B. Girl we have taken in A. So my question is P of B given A. Recall the formula. It is P of A intersection B by P of A. As we know what is A and B. For class 11 they have not mentioned the number exactly. Let us find out what is A intersection B. A tells me girl, B tells me class 11. So intersection tells me girls in class 11. Question itself suggests 20% of the girls studying in class 11 out of this 450. How to find 20% of 450? 20 by 100 into 450, that is 90. What is probability of A intersection B? 90 out of 1,000 students. To substitute in this formula to get the required answer, P of A intersection B is 90 by 1,000 by P of A is 450 by 1,000. 1,000 cancels. I get 90 by 450, which is 1 by 5. This is nothing but the 20%. So this question directly gives me the answer 20%, that is 0.2. I can directly write from the question, or we can work out in steps and arrive at the answer 0.2. Question number 14. From a pack of 52 cards, 2 cards are drawn at random. Find the probability that one is a king and the other is a queen. We know 2 cards are drawn from 52 in 52 C2 ways. Using combination idea, it is 52 into 51 by 1 into 2. That is 1, 3, 2, 6. They have asked probability that one is a king and the other is a queen. How many kings are there in a pack of 52? There are 4 kings, out of which I want 1. There are 4 queens, out of which I want 1. And whenever I have and, I will multiply. Why? They are independent events. Selecting a king or selecting a queen is an independent event. 4C1 is 4. 4C1 is 4. I get 16. What is P of A? N of A by N of S. So P of A, I can write 16 by 1326, which reduces to 0.012. The same problem I can also do without combination. We know there are 4 kings and 4 queens out of 52 cards. My question is 1 king and 1 queen. How the combination would be? First is a king, second is a queen. Or first is a queen and second is a king. So I have 4 kings out of 52 cards. Having selected 1 card, I am left with only 51 cards. In that 51, there are 4 queens, but I want 1. So it is 4 out of 51. The same idea I reverse. Queens first, kings second. 4 out of 52. 1 card is kept aside. The remaining 51 cards, there are 4 kings. Just multiply, add and write the answer. You can either use combination or you can use directly also. Question number 15. A card is drawn from a pack of playing cards and then another card is drawn without replacing the first. What is the probability of drawing 2 aces, 2 spades? As I know, out of 52 cards, 4 kings, ace, queens, jacks are present. The numbers 2 to 10, there are 4 symbols. I want 1 card after another card without replacement. Whenever I see the word without replacement, I can very well use combination. N of S. There are 52. I want 2. So what is my answer? 52 into 51 by 1 into 2. That is 1, 3, 2, 6. 2 aces. Out of 4, I want 2. It is 4 into 3 by 1 into 2. That is 6. P of A. The formula N of A by N of S. It is 6 by 1, 3, 2, 6. Which is equal to 1 by 2, 21. Second subdivision. Selecting 2 spades. Out of 52 cards, there are 4 symbols. Spade, club, heart and diamond. In each symbol, we have 13 cards. My question is 2 spades out of 13 cards. So it is 13C2. 13 into 12 by 1 into 2. It is 78. Probability of B is 78 by 1326, which is 1 by 17, and that is the answer. Question number 6. 2 urns contain the set of balls as follows. 1 ball is drawn from each urn. Find the probability that both are red, both are of same color. Both are red. Let me say A, the event red from urn 1. In urn 1, there are totally 16 plus 9, 25 balls. So total number of balls 25. In urn 2, there are again 25 balls. So what is probability of A? How many red balls? 6 out of 25. What about B? Red from urn 2. 7 red balls out of 25. Selecting a ball from urn 1 or urn 2 or independent events. My question is both are red. So I want A intersection B. In independent events, intersection replaced by multiplication. 6 by 25 into 7 by 25. It is 42 by 625. The second subdivision, both are of same color. There are 3 different colors. Both can be red or both can be white or both can be black. Both are red. Again, independent events. Whenever R comes, remember to add it. Whenever AND comes, let us multiply. Red from urn 1, 6 out of 25. Red from urn 2, 7 out of 25. White from urn 1, 10 out of 25. White from urn 2, 3 out of 25. Black from urn 1, 9 out of 25. And black from urn 2, 15 out of 25. In all the cases, 25 into 25 is the LCM. As I multiply the numerators, 42. 10 into 3, 30. 9 into 15, 135. The total 207 divided by 625. This is both same color probability. So we conclude both to be red 42 by 625 and both are of same color. It is 207 by 625. Bayes theorem, a great milestone in probability. To understand Bayes theorem, let us consider an example. 3 different bags are kept in front of me. Each bag is having some different colored balls, say red, black and white. The balls are different in number in each bag. Supposing, without saying, I select a ball and find it to be red. Now the question is, what is the probability that this red ball is from first bag or from second or from third? So my question can be from first bag. How should I do it? My first question is, if I say red ball, what are all the possibilities for selecting red ball? I can select first bag and then red from it. Or I can select second and red from it. Or I can select third and select red from it. So this I call total probability of selecting a red ball. This we use conditional probability to understand. Now what is my earlier question? The red ball from first bag. So this is designed by Bayes theorem. Let us see exercise problems to understand better. A company has 3 machines A, B, C, which produces 20%, 30% and 50%. Let us write down the probability P of A. 20% tells me 20 by 100. 30% tells me 30 by 100. 50% tells me 50 by 100. So as I read the first line, we have written P of A, P of B, P of C. Their respective defective percentage. So defective from machine A, it is 7%. So I shall write 7 by 100. Defective percentage from B. Defective from B, it is 3 by 100. And defective from C is 5 by 100. So let me say D equal to defective. Now the question is, only one is chosen from these and inspected. If it is defective, so let us find out what is the probability of the chosen one to be defective. How many machines are there? A, B, C. How all could the defective be? It may be a defective from A or from B or from C. So the total defective probability is choosing machine A defective from A or choosing machine B defective from B or choosing machine C and defective from C. Whenever I say and, we multiply. Whenever I say or, we add. Let us just substitute. P of D equals P of A 20 by 100 into defective 7 by 100 plus we just multiply like this. 30 by 100 into 3 by 100 plus 50 by 100 into 5 by 100. Let us take LCM. 100 into 100, it is 10,000. The numerator 20 into 7, 30 into 3, 50 into 5. Together as I add, it is 480 by 10,000. This we call defective probability. I can simplify and write the answer as 48 by 1000 or it is 0.048. Now, the question is, if it is defective, which we have calculated, find the probability that it has been from C. So having defective in my hand, what is the probability that it is from C? So we are writing P of C given D. And this formula we call Bayes theorem. When I want C given D, how should I write it? It is P of C into, just reverse and write, P of D given C divided by total defective probability. Remember, in conditional probability, the denominator will come down. As I substitute, P of C given D equals P of C 50 by 100, P of D by C 5 by 100, and the defective probability 480 by 10,000. As I cancel 100, 100 and 10,000, I am left with 50 into 5 by 480. Zeros cancelled. P of C by D is 25 by 48. As we simplify, we get 0.5208. Since it is a word problem, write the answer as a statement. Question number 7. Bag 1 contains 3 red and 4 black balls. Bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was from bag 1. We are given 2 bags. Let us write down U1 as first bag and U2 as second bag. Having the different colored balls, 3R, 4B, where R is red and B stands for black. Bag 2, we have taken U2, 5R and 6B. R is red and B is black. Now, there are 2 bags. I can select first bag 1 by 2, second bag also 1 by 2. Because there are 2. If there are 3 bags, I will write each bag probability is 1 by 3. If there are 4 bags, each bag probability is 1 by 4. Here we are given 2 bags. Both of them have equal chance of being selected. So P of U1 1 by 2. P of U2 also 1 by 2. Now, red from U1. There are 3 red in U1 out of total number of balls 7. Red from U2. There are 5 red in U2 out of 11 balls. My question is, it is found to be red. So what is the probability of red ball? I can choose first bag and red from it, or second bag and red from it. First bag, the probability 1 by 2, and red from it, it is 3 by 7, plus earn 2, it is 1 by 2, red from bag 2, 5 by 11. It is 3 by 14 plus 5 by 22. Take the LCM and simplify. As we simplify, we get 34 by 77. Now, the second question is, find the probability that it was from bag 1. Having red ball in my hand, what is the probability it is from bag 1? So, I want U1 given R. How to write? Using Bayes theorem. P of U1 given R is P of U1 into P of R given U1. Write the reverse by the total red ball probability. As I substitute, P of U1 by R equals P of U1 1 by 2, P of R by U1 3 by 7 divided by P of R 34 by 77. 3 by 14 into reciprocating 77 by 34. It is 2 times 11 times. I have 33 by 68. So we get the final answer to be 33 by 68. Being word problem, write the answer as a statement. Question number 8. The first of 3 urns contains 7 white and 10 black balls. The second, 5 white and 12 black balls. The third contains 17 white and no black ball. A person chooses an urn at random and draws a ball from it, and the ball is found to be white. Find the probabilities that the ball comes from first or second or third urn. We have the 3 subdivisions separately. How shall we do it? How many urns are given? 3. Let me take probability of U1, probability of U2 and probability of U3. Since there are 3 urns, each will have equal probability, say 1 by 3. If there are 4, we will write 1 by 4 each. The previous problem there were 2. So we wrote 1 by 2 each. Now, urn 1 contains 7 white, 10 black. Urn 2 contains 5 white and 12 black. Urn 3 contains 17 white and 0 black. As I look at, I want, the question is white ball. So white from urn 1, white 7 are there. The total 17 balls. White from urn 2, there are 5 white out of 5 plus 12, 17 balls. And white from urn 3, all are 17. I have 17 out of 17. Now I need white ball probability. How to write this white ball? Select urn 1, white from urn 1, plus select urn 2, white from urn 2, plus select urn 3, white from urn 3. As I simplify, P of U1, 1 by 3 into 7 by 17, 1 by 3 into 5 by 17, 1 by 3 into 17 by 17. For all the 3 terms, the LCM is 3 into 17, that is 51. The numerator 1 into 7, 1 into 5, 1 into 17. So we get 12 plus 17, 29 out of 51. This is probability of selecting white ball. My question is, what is it? The ball comes from first urn. Having selected white in my hand, what is the probability it is from urn 1? How do you write it? U1 into reverse W given U1 divided by P of W. As I substitute the values, it is 1 by 3 into 7 by 17 by P of W, 29 by 51. 3 into 17, 51 cancels. We are left with 7 by 29. To find out white, and it is from urn 2. The formula U2 into reverse W given U2 divided by P of W. So U2 given it is a white ball. We have 1 by 3 into 5 by 17 divided by white ball probability 29 by 51. My answer is 3 into 17, 51 and 51 cancels. I have 5 by 29. What is it? If it is white ball and it is from urn 3, P of U3 into P of reverse W given U3 divided by P of W. So as I substitute the values, 1 by 3, 17 by 17 by 29 by 51. 3 into 17, 51 cancels. My answer is 17 by 29 and the problem is done.